Hello, welcome to Sharp Takes. I have never done this before, so let's get into it. Welcome to Sharp Takes. Sharp is my middle name, Takes is my game. Just kidding, I don't know. Okay, but my middle name is Sharp, that's okay. Anyway, so welcome to Sharp Takes. Today, my sharp take is that a glass of water, half full, half empty. You know the ones where they go, ah, yes. Do. Let's do blue. I like purple better. Okay. Okay. So, you all know the question how full? This is water. This is air. Some will tell you it's 50% air, 50% water, and therefore it's 100% full. My sharp take is that the glass isn't half full, it's not half empty, and it is also not 100% full. They're all wrong. I would like to share with you why I believe the glass is in fact 7.71 times 10 to the negative 14% full. Now that we've introduced the concept of a glass of water and air, let's look at the scales. There are multiple levels to consider. Macro is the obvious general debate. At this level, the glass is half full of water, half full of air, and 100% full of content. To say the glass is half empty is to assume air is a vacuum, which is false. Macro scale is something like a penguin. You can see it, it's big. Next, the molecular level, which intends to discover the amount or volume of nothing between molecules. This assumes molecules take up a finite space with no nothing within. This is an interesting and basic place to start, as there is no need to derive the nothing that exists within the atoms, but acknowledges gaps between matter. Here is a molecule of caffeine. Next, the atomic level, which intends to discover the amount or volume of nothing between atoms, which takes into account how much nothing is within each molecule. So there's an oxygen atom, and it has a nucleus and an electron cloud. The next building block in this puzzle may be referred to as the nucleus level. This accounts for space between molecules, atoms within these molecules, and the space occupied by nothing within the atoms themselves. This nothing within each atom, as taken from the nucleus level, can be broken into two subcategories for consideration. The first assumes the nucleus itself is solid and does not contain nothing. There is no nothing between the protons and neutrons. It instead solely investigates the amount of nothing between electrons and the nucleus. However, since electrons are considered to have no volume as point entities, it is really an approximation based on the volume occupied by the entire atom, including its electron cloud, and subtracting from this the volume of the nucleus to estimate the nothing within each atom. This volume can thus be included in the space between atoms and between molecules. The second acknowledges the nucleus as an amalgamation of protons and neutrons with volumes of nothing between them. It does not take into account any volume of nothing within the protons and neutrons themselves. This requires an understanding of the volume of the nucleus of the atoms in question, as well as the volume of the protons and neutrons themselves. Any isotopes will therefore have varying volumes of nothing. They're made of stuff too. The next layer I would like to consider acknowledges the presence of nothing within protons and neutrons themselves. This requires an understanding of what makes up the volume of protons and neutrons, and deriving this actual volume from the perceived volume given by 4/3 pi r cubed, where r is the radius of either the proton or the neutron. It may be referred to as the inner nuclei level. There are, of course, further levels to descend in the quest to find nothing, but my own current limitations prevent my interest in discovering such, and the assumed limitations of science once you get past quarks and gluons, etc., prevents further investigation on layers even below this. As such, I intend to work my way methodically from the top layer to the inner nuclei level described above. The next question to briefly consider, of course, is the glass itself. Due to the seemingly infinite variations the glass can provide for this question, I prefer to set such boundaries now. The glass is perfectly cylindrical, much more perfect than what I'm drawing right now. The interior surface of the glass is infinitely solid, aka it contains no volume whatsoever of nothing. And on a macro scale, remember the penguin, the glass will always be half full of water and half full of air. The next parameter, which would be prudent to establish prior to beginning this quest, is the composition of the air and the water themselves. Let's assume that the water is 100% H2O. No impurities. No isotopes. And they all are perfect molecules. Also, let's assume there's no effect from capillary action. So it's perfectly horizontal contact between the glass and the air. Let's have the makeup of the air reflect atmospheric conditions. So the air will be 78% nitrogen, which exists as N2, 21% oxygen, which exists as O2, and 1% argon, which is a monatomic gas and simply exists as itself. This last one here is an incorrect assumption because there's actually 0.9% argon in the atmosphere, but for simplicity's sake, the other 0.1% is going to be ignored and instead put into argon. Again, there are no isotopes, and we'll also assume there's no solids. What is the radius? These values are going to be in picometers. The atomic radius of hydrogen is 120 picometers. The atomic radius of oxygen is 152 picometers. The atomic radius of nitrogen is 65 picometers. And the atomic radius of argon is 188. Hydrogen has 1 proton. Oxygen has 8 or 16 for O2. Argon has 18. Nitrogen has 7. Oxygen has 8 or 16 for O2. Argon has 18, and nitrogen has 7 or 14 for N2. Let's go to the volume in picometers cubed of each atom, based off of the formula 4/3 pi r cubed, with the radius in picometers as r. For hydrogen, this means the volume is 7.2 times 10 to the 6 picometers cubed. The volume of oxygen, 14.7 times 10 to the 6 picometers cubed. The volume of argon is 27.8 times 10 to the 6 picometers cubed, and the volume of nitrogen is 1.2 times 10 to the 6 picometers cubed. Now, let's consider the empty volumes of each of these. So, we have the volume here, but that is based off of the radius. Let's now see what's actually inside. So the proton volume, again in picometers cubed, and the neutron volume. Okay. For hydrogen, we have a total proton volume of 3 times 10 to the negative 9. And there's nothing for neutrons. Oxygen, we have 24 times 10 to the negative 9 and 16 times 10 to the negative 9 for neutrons. Argon, we have a proton volume of 54 times 10 to the negative 9 and a neutron volume of 36 times 10 to the negative 9. Lastly, with nitrogen, we have a proton volume of 21 times 10 to the negative 9 and a neutron volume of 14 times 10 to the negative 9. Now, what percent of this volume here is actually occupied by these volumes here? The percent occupied for hydrogen is 4.16, repeating, times 10 to the negative 14%. The percent occupied for oxygen, 1.63 times 10 to the negative 12%. Percent occupied in the volume of argon is 1.94 times 10 to the negative 13%. And for nitrogen, the percent occupied is 1.75 times 10 to the negative 12%. This is based off of the assumption that the proton radius is equal to 0.855 femtometers, or 0.855 times 10 to the negative 3 picometers. The neutron radius is equal to 0.8 femtometers, or 0.8 times 10 to the negative 3 picometers, and that 1 picometer is, or rather, 1 femtometer is equal to 0.001 picometers, otherwise known as 1 times 10 to the negative 3 picometers. Next, we need the bond lengths. This will help determine the size of each molecule. For H2O, the bond length is 96 picometers, and the bond angle is 104.5 degrees. O2 has a bond length of 120.7 picometers. N2 has a bond length of 109 picometers. Alrighty, and argon doesn't need a bond length because argon is monatomic, and therefore it's just sitting, hanging out by itself. For H2O was 3.342 times 10 to the 6 picometers cubed. So, the filled volume of the water is 1.1161 times 10 to the 35 picometers cubed over the available volume of 1 times 10 to the 36 picometers cubed, which is equal to 1 meter cubed, and then times 100 to get our percent. 11% approximately of the water is occupied by molecules. So, we got the penguin, that's the glass. Now we're moving on to the molecules, that's the caffeine. One molecule of H2O has 10 protons and 8 neutrons. As previously determined, the volume of a proton is 3 times 10 to the negative 9 picometers cubed, and the volume of a neutron is 2 times 10 to the negative 9 picometers cubed times 10 here times 8 here, and then add those two together. So we have 46 times 10 to the negative 9 picometers cubed per molecule occupied. Times 33.396 times 10 to the 27 molecules of H2O per glass and molecule unit cancels out with molecules, and this leads us to 1.536 blah 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 times 10 to the 21 picometers cubed per glass is occupied. Okay, so filled volume over available volume times 100%. All this equals 1.5362 times 10 to the negative 13% of the water is occupied. Now, onto the gas. As a reminder, we're working with 78% nitrogen, presenting as N2, 21% oxygen, presenting as O2, and 1 beautiful percent of argon, presenting as itself, as our composition. Again, we're at a temperature of 20 degrees Celsius and a pressure of 1 atmosphere. Given all this information and doing the math as above, we get the glass is a total of 7.7 0.71 times 10 to the negative 14% full of air and water. And that was today's Sharp Take. Woo! Thanks for watching. Please like, comment, and subscribe.